know, people see fire and they say, ah, it's hot, it glows, it burns. But if you really want to understand why fire burns, not just that it burns, you've got to go deeper, much deeper. And the funny thing is, fire isn't a thing at all. It's not like wood or water or iron. Fire is a process, a dance, a conversation between atoms. Let me tell you the story. Imagine a piece of wood. Looks solid, right? But inside it's full of complicated molecules, mostly cellulose, made of carbon, hydrogen, and oxygen, all tangled together like spaghetti. Like spaghetti, these molecules are in a kind of strained state. They've got energy stored in their bonds, like a spring wound up tight. Now bring in some heat, a match, a spark. That little jolt gives a few molecules enough energy to break apart. And when they do, they meet oxygen from the air. Ah, oxygen is the key. Oxygen is greedy, it loves to grab electrons, and carbon and hydrogen, they're happy to give them up, but only if you help them get started. That's what the match does. It pays the entry fee. Once the reaction begins, something beautiful happens. The carbon and hydrogen atoms rearrange themselves with oxygen to form new molecules, mostly carbon dioxide and water vapor. And here's the magic. The new arrangement has less energy than the old one. So where does that extra energy go? It doesn't vanish. It flies out as motion, frantic, chaotic motion of the new molecules. And what do we call frantic? Molecular motion. Heat, and not just heat, some of that energy also excites electrons in the atoms. When those electrons fall back down, they spit out light. That's the glow you see, the yellow, orange, red flicker of the flame. So fire is really just atoms rearranging, releasing energy as light and heat. But wait, why doesn't wood just explode all at once? Why does it burn slowly? Because the reaction needs oxygen to reach the fuel and heat to keep going. So the flame itself creates a little zone of hot gas that keeps breaking more molecules apart, which meet more oxygen, which releases more heat, and so on. It's a self-sustaining chain, a controlled avalanche of chemistry. And the smoke? The leftovers, unburned carbon particles, tar, bits of stuff that didn't get enough oxygen. If you give it perfect conditions, pure oxygen, fine powder, it can explode. Like in a flour mill, same chemistry, just faster. Now, here's a thought. There's no fire substance. No phlogiston, that old idea that things contain a burning essence. We used to believe that, but it's nonsense. Fire is just chemistry in action, oxidation, to be precise. Rusting is the same thing, just slower. If you could speed up rusting, you'd get fire. So next time you watch a campfire, don't just see flames. See trillions of atoms shaking hands with oxygen, letting go of old bonds, forming new ones, and shouting their joy as light and heat. That's not magic. That's physics. Physics. And it's happening all around us quietly, constantly, beautifully. All you need is a little curiosity and maybe a match.